All right, this here is 1. Let's look at number 2 here. It says if the base of a triangle, if the base of a triangle B of a if the base B of a triangle is increasing at a rate of 3 centimeters per second while its height h is decreasing at a rate of 3 centimeters per second, which of the following must be true about the area of a triangle? And it says here, A here says that A is always increasing, A is always decreasing, A is decreasing only when BH. I might have to open up this. Maybe does this give me a? Let me see if this gives me a picture here. Give me a second here. Maybe this would give me a picture. Yeah. So this is a picture of the solution here. So it says if base B of a triangle is increasing at a rate of 3 centimeters per second while its height h is decreasing at a rate of 3 centimeters per second, which of the following must be true about the area of the triangle here? So we're given here, let me see if I can move this over. Yeah, we're given, let's see, we're given, let's write down givens here. So we have base of triangle, so we have some type of triangle here. And it's base here, so the base of the triangle, and it doesn't tell us what triangle it is. So maybe I'll just do I'll just do a right triangle. So here the base here is increasing by a factor of 3 centimeters a second, while its height is decreasing by a height equals minus 3 centimeters a second here. Which of the following must be true about, and we care about the area of the triangle here. The area of a triangle, which is half BH, right? Half of base times height here. And it's saying here, it gives us here A is increasing, A is decreasing, A is increasing only when B is less than H, A is decreasing only when B is greater than H, and E remains constant here. So I'm just going to look at the solution here, and it says that for an area of triangle here, differentiating with respect to time, if B is greater than H, then area will decrease to time. Hence, option D here is the correct answer. So they're saying that they can differentiate this kind of function in respect to time here. So I would have to basically do something like this. I would have to take the area. So I can basically plug this in, right? I can say area here equals half of base here. I can say it's 3 centimeters per second times negative 3 centimeters per second here. And I have to figure out some type of formula here in order for us to differentiate this equation. So it says here, if I'm differentiating with respect to time, but I have to create, the student didn't actually create a formula or a solution here that actually let me figure out what that formula is in terms of in respect to time here. So let me see if I can figure this out here. So it says increasing at a rate, decreasing at a rate of centimeters per second, and I care about the area of the triangle. So I would have to basically figure out some type of formula that has to relate these two terms together in respect to time here. So I would have to do maybe area over time here. A at t would equal, or I could keep the time constant here, and maybe get rid of the t here. So if I take a constant time, let's say maybe 10 seconds, we can say here, maybe let's take here at t equals 10 seconds. What would my what would my values be here? So if t equals 10 seconds here, then my base here would be 30 centimeters. And my height would be negative 30 centimeters here, right? And you would get a value of, let's see, 15 times negative 30, which could negative 450 centimeters squared here. So this would give me a negative area, which doesn't really make sense here, because again, this is simply just the rate at which it decreases here. So it says here, the student picked D as the answer. So it says here, if B is greater than H, if base is greater than H, then area will decrease with respect to time. So if base is greater than the height here, then area will decrease with respect into time. Okay. So therefore, hence D is the correct solution. So I'm going to visualize this and say if B is less than H here. So if B here, let me erase this here. If our base is greater than our height, let's say if our base here is, let's put 10 here, let's put like a 5 here maybe, this would be centimeters. We're just kind of throwing out numbers. If 10 here is greater than height here, area will decrease with respect to time. And this solution here is correct because it's saying, again, as my height decreases, my base increases, right? So, and again, depending on how fast, again, it's how fast it's decreasing. It's 3 centimeters and -3 centimeters, so it's actually the same rate of decrease here. But my base will always start slightly higher, and my height will start slightly smaller, right? So again, if I were to solve this equation here, A equals half BH, and with these two numbers here, so A equals half BH, and A would equal half times the base here, which is 10 times the height here. This would give me 25 centimeters squared. However, if I flipped it, and if I said base is 5 and the height is 10, I would get the actually exact same height here. But depending on the rate at which it decreases, area will also decrease in perspective time. So in this case, I'm going to write here solution here. Solution here is correct, but no explanation is given as to differentiating with respect to time.